good evening, welcome. It is Thursday, the 18th of March 2021, and we're back and we're doing more mad stuff with C Sharp and .NET. And I just watched a thing on the news on CNN about Super Mario World, which opened today in Osaka, Universal Studios, which looks awesome, and I want to go, but it's not. It's in Japan, and that's like a really long way, and I don't want to have to go to Japan just to do that. And the one in Orlando isn't going to open until 2025 apparently, and I'll be 52 by the time that opens, and then I won't like Mario anymore because I'll be old and sensible and boring, and I'll have lost my joy. So I'm sad. Lost my joy already. But yeah, so I'm going to take my mind off it by doing ridiculous things with code. So when we left it on Tuesday, I was basically tying myself in knots trying to generate C# code that would hard coded against roots from a Blazor or an MVC application or something, to do really optimized matching, to kind of go, does this path match against one of those routes or doesn't it? I don't know. We'll find out. Let's see. And yeah, and I said I was going to do some work offline, and then I had a bit of a fiddle with it, and I think it works. And I think it worked even when I was kind of going, this is terrible, and I can't code, and nothing works. But we'll see. So what I was doing was generating the code and then kind of having a const string with all the code against it in my application here. And then I thought, what would actually be better? Because this is intended to end up in a source generator, which means doing Roslyn-y things. And I thought, well, if I'm doing Roslyn-y things, then what I'm going to do is build the code at test time. So get the code to here, and then compile it using Roslyn into an in-memory assembly, and then create an instance of the class that's generated, and get the method off it, and then test stuff against that. So that is what I am going to attempt to do right here. So this now is the right code. So that's all working, and so and I've added my dependency on Microsoft.codeanalysis.C#, which is where the stuff lives for building C# at runtime and stuff. And so I'm just going to, and I've got a blog post that shows me roughly how to do this. And so what we basically need is we can get the syntax. So we've got actual, and actual dot is now the text that came from our target, and so we can say var syntax equals C# syntax tree dot parse text actual. So that has now passed the C# into something useful. And then we want to create a compilation from that. But before we can create the compilation, we need references, because we need to say you're going to reference this assembly from the SDK and stuff. And so we only need the sort of effectively mscorelib or system.private.corelib or whatever it might be. And so we're going to say var ref paths equals new, and then in here we're going to say type of object .assembly.location. So that should be a path to wherever this lives on the disk. And then we can, at the end of this, put .select p2. Let's just change this to references. References. I know how to spell reference, I just don't know when to stop. So we're going to use metadata reference.create from file p, and then we're going to say .to array on there, and then we can say var compilation equals C# compilation.create, and then we need an assembly name. So we can just say var assembly name equals path.getRandomFileName, because we don't care what it's actually called. We just want to give it one. Assembly name, and then new syntax to pass the syntax tree in, and then references, and then we want a new C# compilation options. This is a really weird thing that Rider does. When it sort of automatically fills out the new, it's forgotten to take the question mark off the end because it's a nullable. And then this is going to be output kind.dynamically linked library. So that has now that's a compiler or a compilation task that's going to run. So effectively running CSC on our code there, and then we need somewhere to compile it to. So we're going to say using var ms equals new memory stream, and then we can say var result equals ms compilation.emit ms. So that will now just emit the compiled C# into that memory stream there, still showing big Mark. There we go, there's little Mark. Thank you very much. Everybody's just sitting there going, yep, we'll just let him carry on. Look at the big idiot just telling us all this stuff he's doing while he's all over the top of it. Just, yeah, I apologise. Right, anyway, there you go. Now you can see all the stuff I've been talking about. I need a producer. That's what I need. And then we need to load this into memory. And so we can say ms.position equals 0 to move the stream back to the start. And then we can say var assembly equals assembly load context dot default dot load from stream ms. Oh, hang on, we just want to do one thing up here. We can say assert dot true result dot success, and if that fails, then we can sort of debug into here. Actually, we can probably get the I output helper thing. So we can say, let's do a ctor and I test output helper. And then down here, we can say if result.diagnostics.count length is greater than 0. That's going to be an immutable array of diagnostic. Yes, everything in Roslyn is an immutable array or an immutable dictionary or an immutable There's an immutable list as well as an immutable array, which is weird. I don't know why you would have both, but you do. Then we can say for each in result dot diagnostics underscore, let me this static, I'm going to do that, output dot right line diagnostic dot to string. There we go. So now if there are compiler errors, then they'll get written to the XUnit test output, which will be super helpful. So then we can say assembly is assembly load context.default.load from stream, and then we should be able to say type equals assembly.get type, and we just need the class, fully qualified class name there. And then we can say method equals type.get method is match. We can say assert.notNull type, and then we can say assert.notNull method, and that should work as well. And then we can say obj equals activator.create instance of type. And then we can return method.create delegate func of string comma bool obj. Okay, so generate the code up here. Create the references, pass the code, create a compilation, run the compilation into a memory stream, reset the memory stream back to 0, do the diagnostics before asserting true on result.success, so those will always get written out if there are any. Load the assembly from the stream that we've just compiled in memory, grab the type, grab the isMatch method off the type, create an instance of the type, and then create a delegate of func string bool. And then up here, this test method should now do all the things that it is supposed to do. So if I run this, yay! So that's fun. So the really fun thing to do there so I'm going to add on inline data /files /foo/bar/quux.pdf, and then down here I'm going to put in /files/ star path like that, and then we can run this again, and it doesn't like that one. So yeah, that should match anything that starts with files. So in my root tester generator here, I've got my right switch. So if res.length is 0, we can put in if subroot dot is wildcard, code.append line return true, like so. And then else well, let's just see what it does. Evening, Rambling Geek, how's it going? Okay, good to hear. So let's just see if this is actually getting hit here. And no, it isn't. So where's my thing here? What I'm trying to do overall is the end game is to create a source generator, a C#9 source generator, that will generate a class. And so what the source generator will do is it will look at a project and find all the roots from root attributes on Blazor page components, and then it will generate a class that will really super quickly, you give it an actual path and it tells you if it matches any of those Blazor roots. Doing it, the idea is that doing it with a source generator, you can actually generate hard code to do this with switch statements and equal statements and like super optimized and zero allocations. And it should should be super fast, basically, is the idea. I don't know if ASP.NET Core is doing this yet. I know they've just rewritten or redone in .NET 6 Preview 2. The Razor compilation is now done using source generators, which apparently has just improved the compilation performance of ASP.NET a lot. And that's quite exciting. But there's a bunch of stuff that's happening in ASP.NET Core in particular, where being able to generate source code at compile time just by magic, there's a bunch of things that could make a lot faster. So Razor compilation, it was already doing that. Razor pages have to get compiled to C# as part of the process. But routing, you can generate code that you wouldn't. The nice thing about CodeGen is you can generate code you would never ever write, and it doesn't matter. The compiler likes it. It's like the way compilers actually rewrite your code, like unrolling loops and introducing go-tos and stuff. But yeah, JSON serialization is the other one. and deserialization. And yeah, so you can do this at the moment, and there are when I was working on Simple Data, which was my dynamic ORM, I did a bunch of runtime code gen using il.emit to do things faster. And then I switched over to using link expression trees and compiling link expression trees, just to try and improve stuff, which is also how Dapper handles its object mapping. It builds expression trees and so forth. But the downside with that is that Microsoft are moving towards providing ahead of time compilation of .NET, of C# and F# and VB.NET. And as it stands at the moment, they can do ahead of time compilation of all the code that exists at compile time, but anything that's doing emit, anything that's compiling link expression trees at runtime, it still needs the JIT to then turn, because emit, il.emit, or compiling an expression tree produces IL, and if to actually run that, you need it to be turned into machine code or potentially WebAssembly if you're running in a browser in Blazor or something, which means you have to distribute the JIT, and the JIT's quite big. There's a lot of code in the just-in-time compiler. Or you have to say anything that uses dynamic code gen at runtime isn't going to work in this. So like CoreRT, which was 3-4 years ago, it was a project to create a completely ahead of time native compiled version of .NET, which has kind of morphed into the whole AOT thing that's happening now. But yeah, if you don't use CodeGen for things like serialization and object relational mappers and that stuff, then it runs very, very slowly because you're basically doing reflection at runtime. If you do use CodeGen, it means you have to distribute the JIT and you can't do full AOT compilation. So if all the stuff that's currently using CodeGen, whether that's routing or serialization or entity framework, object mapping, or any of that sort of stuff, if all of that can be done using source generators at build time, then you get the best of both worlds. Everything can be ahead of time compiled, and everything is kind of code-genned. So it's pretty cool. If you look at some of the other stuff out there at the moment that's got a real pathological focus on performance, so like Rust, for example, the main serialization crate for Rust is called Serde, or Serde, 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 serialize, deserialize. And it's not a library, it's a macro, or it's a bunch of macros. And so you add a trait to a struct and say this implements the serialize, deserialize trait, and it generates the code to serialize and deserialize that struct to and from JSON. So it's full native code. And so building something like that into .NET could massively improve performance. And it also means that when they do stuff like profile guided optimization, the profile guided optimization can probably do exciting things. What's the debugging experience like with CodeGen code? It's surprisingly good, because this is the thing. The code is generated into your project. So it actually exists. It goes into the OBJ folder, I think. So if you look at something like gRPC, which I've done a lot of stuff with the gRPC in Netcore 3.1 and .NET 5, doing a workshop on it at NDC Manchester next week. The code is generated into the OBJ folder, and so you've got like if you've got a gRPC service called customers, then there's a customers.cs sitting in there, which has got all the protobuf generated code. And so when you are debugging, you can step into it and you can step through it and all this sort of stuff. And so yes, you can, if we get the source generator done, I'll be able to show you how that works. So yes, but yeah, and it's even magical. So you can, with source generators, you can create a class, and this is something I'm actually thinking of doing once I'm done with this. The next sort of fun thing to do on the stream, I think you can create a class and you can put an attribute on it with a database connection string, and then just from that one attribute you can fill that class with properties for the tables. So essentially creating like an entity framework DB context, and yeah, and it would do stuff for that, I think, probably. So yes, basically like simple data, where it was a dynamic object, and then you'd say db.customers.findById, and at runtime it would just dynamically figure out what that meant. I think you can do that in a source generator, but the experience of doing it is you create an empty partial class and you put that attribute on it, and then the source generator goes run, and then you actually get the IntelliSense on that class while you're working with it. So it's not dynamic, it's statically typed, and it actually has the properties and everything. And yeah, so fun basically, is my theory. So yeah, okay, what are we doing? So we've got this bit here, and let's just debug this. Okay. So that S, and then we've got this one which says is start and is wildcard. Okay, so in our root tester generator here, carry on. So this root here is got O and E. So I want to put my thing here, C equals S. Done. Okay. Do. There's that blimmin' asterisk thing there, and I don't know what that means. Oh no, that goes at the end. Right, so var subroot equals root.getRoot C. So we're going to put a breakpoint here and we're going to do a condition C equals S. And then we'll just debug through this again. Why are you not breaking on there? Okay. So this is start is true and is wildcard is true. Okay. So carry on. Why is that? That should be breaking there. Okay, let's go through this again. Values P and F. Values O and E. Terminate child processes. That's slightly bizarre. Let's jump back down to here and set a breakpoint here and we'll debug this and we'll see what this is generating. So actual copy value and then so we got a switch case P, case F, ILES. How did you generate this? How did you generate this code without triggering that breakpoint, you impossible? Right. Root tester generator. So we are going to set a breakpoint here and we're going to say oh no, that's why it's not breaking, isn't it? Look, if values.length is doing that and then doing this, because we've got if values.length is greater than 1 else, it's not going in here. I've basically got a bunch of code duplication here that I should probably tidy up. Because up here it's doing, there's somewhere where it's doing a switch. So this is doing the switch, and then all this stuff's inside here, and then this is doing an if, because there's only one thing in there. And so now yes, there we go. This is what you get for copying and pasting code and not doing stuff with it. Right. So now here's an even more fun bit. I'm going to just quickly, let's delete all my breakpoints again. Remove all line breakpoints. And then we go to here, and then and I'm going to debug this, and I'm going to copy this code, and we can just stop, and then I'm going to go into benchmarks, and I'm going to go into here, I'm going to insert class root tester generated. Nope, never ever ask, just stop asking that, basically. Right, so here is my generated code, and I'm going to bang that into there like that, and then in root benchmarks I'm going to go so private static read only RTG, RTG equals new, and then I'm going to come down to here, and I'm going to change the name of this to generated, and we're going to do that, and this should all still work because those are all in my tests that I was using there. And then we can jump out to here, and we can cd into sandbox root spike benchmarks, and then we can do .NET run -c release, and we'll see how our generated code compares to our handwritten code. So this, I believe this is the one that's doing it with regexes. This is like the blatant just don't baseline that we have for our benchmark. And then this is the one that magic. Yes. Oh, it is. It's like magic. This is the hand-coded one that I did to test what was actually I created the code that I then thought I wanted to generate, so I was kind of building myself a map to the kind of code that I wanted to generate. And then this is my generated code. And like I say, this is code that you would never write. You would never write this code by hand. But it is super fast. It is really, really quick. So let's just jump back to here. Why question mark de verbose? Why wouldn't you write? Because, well, let's. So there are two reasons. One is that the source generator is actually going to build this dynamically from the roots that are in your application. And so if you add a new root to the application, the generator will just automatically update this generated code to include your new roots. So you don't have to maintain two things. But the other reason, frankly, why you wouldn't write this by hand is because, oh my God, look at it. And this is just for a handful of root patterns. This, if you think of the average, even just an e-commerce site, but the average website, you've probably got a few dozen roots, 30, 40, 50 roots, just for a small website. And so, yeah, this code is going to become long and really, really complicated. And you've got switch statements and if statements and all sorts of nonsense in there. And I mean, I'm generating code that I don't need to generate. And you end up generating code that you don't understand, and code that doesn't work, or code that works but you don't know why it works. That's the best kind of code, is the code where it works but you have no idea why. Now, one last thing that I want to try. Yeah, basically it is. It's very much like AI. Imagine if you gave an AI its own code and went optimize that. There was a thing. What was I thinking about with AI earlier on? Oh, yes. I've been reading Reality Is Not What You Think, which is a book about quantum and the search for a quantum theory of gravity. Because at the moment we've got general relativity, which describes gravity and how that works, and we've got quantum mechanics, which describes everything else. But quantum mechanics doesn't describe gravity, and general relativity doesn't describe atoms and particles and electrons and photons and all that good stuff. And they're completely incompatible. But there's a bit in the book where he's talking about Dirac and Niels Bohr and Heisenberg, the guy with the uncertainty principle, and Schrödinger and Max Planck and all these guys. And what quantum mechanics is it's a bunch of equations, and the equations make predictions, and then when you test the predictions you go, yes, no, that is the way reality works. And it's really disturbing because you're kind of going, in between an electron being here and here, it's nowhere, and it's also everywhere at once. There's more probability that it's here than that it's in orbit around Jupiter. But yeah, and yes, and so the idea is to find the equation that works. And I thought, I wonder if that thing, that AI that they've got that's generating code and generating stories and whatever, the OpenAI project that Microsoft have got running on Azure, if you just gave that the facts and said, find equations for quantum theory that explain gravity, and just let it go, how long would it take it to figure it out? That was what I was wondering. Anyway, this is not a quantum mechanics lecture. This is streaming and writing code. So the other thing that I wanted to do though quickly is so down here we've got this if static, right. So up at the top here, I'm doing this thing where I find all the roots that don't contain any parameters, and I'm sticking them into a hash table, and then just doing a shortcut check against that. What I want to test is if I don't do that, and if I just say underscore statics equals new, then first thing, do my tests still pass? And no, they don't, because the index was outside the bounds of the array. So that's interesting. So root tester generator. Switch ch. Do. So let's just jump back. Let's debug this again. And grab this code and switch out to here. Right, so POSTS is this going to be another one where I haven't done this? Right. F9 and then C equals S, and then debug this test again. So root dot subroots, this is going to be the T. So C is S. Root to do S. Subroot. Okay, just carry on. Okay, so now my subroot is star, is asterisk, root, and we've got a subroot P, which has got two subroots, one of which is O, which has got a single subroot, which is S, which has got a single subroot, which is T, which has got a single subroot, which is S, and that should be true. And this start should not be true. Why is that? That's just nuts. Let's go and look at our root thing here. Okay, so let's debug through this. So part and parts. Okay. Oh, you stupid, stupid, stupid boy. Root tester generator. Right, this might work. No, it doesn't, but that is at least better. Right, let's debug this again. So yeah, I wasn't. So parts is just posts at this point. So now da-dum. And then we can go into there. And so now parts 0 is OSTS. And then in here, this is just STS parts, and now this is TS, and then again, and this is just S. Right. Okay, so that's good. And then if I go clear that breakpoint out of there, so subroot here has got, this is the T. So if I go through again, this is now the subroot for the S at the end of posts. So this should be if subroot is end. And equally up here, it should be subroot dot is end. And now this should work. Yeah. Happy, happy, joy, joy. Right. Because my further theory is that actually just doing this with generated code is probably going to be quicker than the hash set. I don't know how optimized the hash set is internally, but it's a case insensitive, and this is automatically case insensitive. So we're going to do a quick debug on this, and we're going to get our actual here. We're going to copy that value, and then we're going to stop, and then we're going to go up to our benchmarks, and we're going to add a class root tester no hash set. And move that over to there, and then in our root benchmarks, we're going to root tester no hash set is root tester no hash set, and then down here we're going to grab this, and we're going to say no hash set, and let's see how quick this is. I think this is going to be faster, so we shall see. So let me know in the chat if you think this is going to be faster or slower without running everything through a case insensitive hash set to see if it matches one of the static paths. Faster from Rambling Geek. I think it's going to be faster. So this is my hand coded. I could probably have commented these out, but when you kind of realise partway through the benchmarking run that you could have commented the first two out, but then you're like, well, they've run now, so I might as well just let them carry on. And then this is generated. Do 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 do. And then this. Oh wow! That's not just a little bit faster. That's a chunk faster. That's astonishingly fast. So from the so this is my Blazor roots. Okay, this is the one that was just using string.split and then doing comparisons against it. This was my absolute bare minimum that I wrote just to get Cocoon working with Blazor server at the time. So this is currently what is in the library that's published on NuGet, and then this was my where was my handwritten one? This is my handwritten one. So yes, I did basically write the code, and that does a bunch of stuff, but that's doing like sequence equal and things. This is generated with a hash set, which has only got 2 values in it, but it's comparing everything against that, and then without the hash set, it actually runs faster. That's insane how much faster that is. I'm super happy. Yeah. So now let's try and let's see if we can hook this up into a source generator. And then we can do some fun things against it. So, bum 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 bum. Root tester gen. Yeah, this is NetStandard 2.0. That's good. I wanted that. So cd dot dot slash dot dot .NET new class lib dash dash framework NetStandard 2.0 minus o src slash my source generator. Why not? .NET sln add src slash my source generator. Okay, and then I'm just going to there's a really helpful blog post. Andrew Locke. Andrew Locke, Blazor source generators. So Andrew Locke, who is a dude and has a blog and writes some really cool stuff. Basically, he has this sample code, which is for it's for a similar thing, but it's for dynamically generating a menu from the roots in a Blazor application. And I haven't written a source generator before, so I'm just going to borrow some of Andrew's code here. Okay, so if we look at the CS proj, we have not sure why he's got that there, unless it's just that this was from a while ago. But we need Microsoft Code Analysis C# workspaces. So dependencies, manage NuGet, Code Analysis, C# workspaces. We'll add that in there. And Microsoft.codeanalysis.analyzers, and we'll add that in there as well. And so that looks good. Close other tabs. Root tester gen. we need system.memory because that is not built in to NetStandard 2.0. So system.memory, span, memory, all those things only turned up in NetStandard 2.1 and NetCore 3.0 and onwards. NetStandard 2.1 was NetCore 3, wasn't it? I think. Yes. Right. And then we can rename this to root tester source generator. And we can implement iSource generator on here. Okay. And then we can also put the generator attribute on there, like so. So templates approots generator. So this code here is the code to find all the roots in an application. Okay. So we can bring in the missing references there. And then root attribute name goes to there. Initialize is not doing anything at all. We don't care about that. And then we've got this code here. Okay, so root tester gen. Let's, for now, we'll just add a reference to it, like so. So that we can say var generator equals new root tester generator all root paths, and then this can just become generator.generate. Okay. Ba-bum-bum. Right. So if we go back out to here, and then Blazor app 1, and look at the CS_proj file. So this is where he adds a reference to it. Do 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 do. Where are you not working? Let's Lang version latest. That's good. Right, and now we can create .NET new xunit -o test / my source generator .tests. .NET sln add test / my source generator .tests. Okay. And now in here we can do add reference to my source generator. Okay. And then we need to change the actual project reference here. So that we have these two things in it. So reference output assembly is false and output item type equals analyzer. Okay. And I'm just going to knock that across there. So now theoretically, he said, theoretically, this my source generator here we can say if all root paths dot length equals 0, return, because we don't want to generate anything. So this is looking for Microsoft.ASP.NET Core.Components.root attribute. Okay. So in here, I'm going to add a new class, root attribute, and I'm just going to change its namespace . Okay. Get semantic model, get the argument list 0, so this just needs to have private read only string underscore path, doesn't matter, initialize field from constructor, and then down here I can just have a public class foo, and this can have root foo, I think. Yep. And we can do another one, and we're going to call this bar, and that's going to be bar. Right. Now, in theory, show in Explorer, open with code, obj, debug, so this is not currently generating anything. I think that is because, well, no, let's enable nullable in this thing. Stop the nullable lies. See, this is the fun thing, is how do you debug all of this stuff here? That is the fun bit. I think if I grab that, and then I put that there, because when Microsoft generate code, these things are being generated from Razor files. So build, fail to generate source, could not load file or assembly root tester gen, the system cannot find the file specified. Okay, so let's just go to here and we'll take this out. Maybe it's not allowed to reference other projects, in which case we will just copy these classes and paste them up to here, and then we can build this. Don't care, don't care, don't care, don't care. Not using them. Right. So now we can rebuild this. Interesting. And jump back over to here. And so root tester source generator. So this is just going to generate something empty if it's not matching the roots. Build selected projects. Is it? So var target equals new root tester. Where are you? Where are you? Where are you? Where are you? Copy path. Right. There you go. That's where the source code is hiding that has been generated by this. It's hiding off in rider source generated documents a something something my source generator. So yeah, here you can see the stuff that's been generated like that. Okay, so that's good. Let's just if I do that without the root, like so, and save that, and go over to there now. Yep, there's no Q in there. Let me just see, that actually gets changed dynamically. I don't have to compile, I don't have to build, I don't have to save or anything. It just magically happens. But as it stands at the moment, I'm not wild about the way that is finding paths. So I'm going to internal static class template finder, single responsibility principle, whatever. So this we're going to have a private read-only hash set of string root attribute names equals new, and this is going to have root attribute name or just root or root attribute. Okay, because the problem is what we're doing at the moment is we're looking at the syntax, and the syntax is literally the word that was written there. And so in the generated code, it's fully qualified, because when you're generating code, you tend to fully qualify everything just because you don't know what else is not the code that I'm generating. So the code that the Razor compiler produces from the Razor file, if you look at the C# that's generated from that, it has the attribute name is fully qualified, but I don't want to tie myself too strongly to that. And so what I'm going to do is I'm going to go into here and say root attribute static, root attribute name static dot contains attribute name to string. Right. So that's going to find things that match that. So that should now find root and everything else. Template finder dot get root templates, uncomment that because we're not going to generate the code if it's not there. So this build that, and then build this, and then jump back over to here, F, B, Q. So now it's matching root as well, which is good. We want that. But there might be other roots in there. There might be like MVC roots in there that we don't want to match. There could be just random, somebody could have created their own root stuff in there. So what we can do then is we can, down here, we're getting the semantic model. So with Roslyn, you've got two sides of everything. You've got a syntax tree, which is the code, the tokens, the braces, and the white space, and the comments, and everything else is in the syntax tree. And then you have this other thing, which is the semantic model, which is what all that actually means. And so from this semantic model here, we can say semantic model dot get declared symbol component dot syntax tree dot get root. Root attribute is an attribute syntax. Dot get symbol info root attribute dot symbol, and then we can say if symbol is I named type symbol if named type symbol dollar name type symbol dot containing namespace dot named type symbol dot name, full name equals root attribute name. So this will now get the namespace qualified name of whatever this attribute is. Otherwise we can return null. Okay, so then we can build this again. And then we can build this again. And then we can go back to here, and this is still doing this. Okay. But if I go down to here, rebuild selected project. Go away. And advanced build actions, rebuild selected project. Okay, so that's now not generating anything at all. That's supremely unhelpful. How can I deal with that? Template finder. Get type info. Bum 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 bum. Debugger.launch. Build. Choose just-in-time debugger. Okay. We're going to open Visual Studio now to debug into this. This is how you debug source generators, apparently. Awesome. So much fun. Right, so symbol. F. What is it then? Symbol. This is Visual Studio, just taking a while to boot up on my machine. Oh, okay, it's a method symbol. Oh, of course it is, because it's a constructor. Constructed from. So symbol dot method symbol Microsoft.codeanalysis. You're not going to let me do that, are you? Right. Don't save. Right. So in here we are going to say if symbol is method symbol, add braces, method symbol dot I need some sort of containing type thing here. Containing type. Method symbol dot containing type. Okay. And then build this. And do this again. Opening this up in Visual Studio 2019. JetBrains.resharper.roslyn.worker this is apparently. So now I've got my method symbol. Come on. And there we go. So now my full type name is what I wanted it to be. So that, no, go away, do that, don't save, go away, do that, build this, back to here, and again this, right, yes, there we go. Now the fun thing with that is that here we've got like root attribute has gone into there. So I can remove my redundant qualifier from that one. So that's going to be root attribute. That's the fully qualified one. That's just got root on it. But if I add a new class in here called dummy, and in here I'm going to put an internal class root attribute, string dummy, and then on here I put root dummy, right? This should not get caught now, because I'm basically going, have you got something that's either called root or root attribute or the fully qualified name of the root thing? And then I'm actually doing a test to make sure that it is the thing that I actually want. So if I now build this source generator again, nope, hang on. Yeah, so if I now go to my root tester here, it's only finding bar. Why are you only finding bar? Debugger.launch. That is entirely possible. So let's go to here, and I'm going to move this into a namespace dummy all by itself. Yes, good call, Des. Thanks for that. And then jump over to here now. This looks, yep, there we go. Foo, bar, and QUUX, but no dummy. Right. Awesome. That's it. It works. I wrote my first source generator. And I'm really, I haven't explored them at all. I haven't messed about with them at all. And I am now extremely happy. So the next thing to find out, which is going to have to wait until next Tuesday because it's stopping time and I've got to go and watch Paddington and I am just shattered. I'm not sure how these work as NuGet packages. And I don't know. I will just go somewhere and ask, I think is probably the easiest thing, or just do it as an experiment. If you have to reference the package directly, I'm guessing you probably don't, because you're not going to have to add a new reference. If it's in, if the cocoon.blazor server package takes a dependency on this root tester generator type, then will it generate code? Or do you have to reference the thing directly? Because there's some interesting stuff. If you reference a NuGet package that references a NuGet package that references a NuGet package that generates code, I can see people getting upset about that. But anyway, we shall explore that next week. And then we'll see what happens after that. But I am seriously considering taking a quick look at the database idea and just going, could we generate code to map to a database, and what would that look like? and stuff. So yeah, um, right. So that's it for today. I will get all this kind of neatly tied up with a bow and put into a project in the actual Cocoon solution, and pushed up to GitHub, and I'll tweet when I've done that. And I've got to write some docs and stuff for Cocoon as well. Still haven't got around to doing that. So yes, anyway, that's it for tonight. I'll be back on Tuesday at 7 o'clock next week, to do whatever it is we do next. Probably just finishing off this and checking whether the root tester generation works. And if it does, then that's awesome. And if it doesn't, then we'll deal with that. And apart from that, yeah, thanks for joining me. As usual, much appreciated. I will see you next Tuesday. And in the meantime, have great rest of the week, fantastic weekends, take care of yourselves, and I will see you next week. Cheers. Bye.